Okay, welcome back to part 2 of our unit review, test review on logarithms. We'll do questions 11 through 20, so I recommend that you have your review packet in front of you and follow along with those problems. All right, so 11 and 12, we are supposed to rewrite the equation in log form. So they're given to us in exponential form. So if you look at number 11, remember we said there's really three parts. There's the log, the base, and the antilog. The log is 2, the base is 16, and the antilog is 256. So the way I would write this in log form is I would start finding the log and write 2 equals log, then fill in the base log. So 2 equals log base 16 of 256. And there you have it. It's in log form. Same thing in number 12. You got 2 to the y power equals x. I'm going to find the log first. So y equals log. Write that down. Then the base is written, of course, really small and low by the g. So 2 equals log base, y equals log base 2 of x. So you can think about that one. Okay, so the next two problems are going in the opposite direction. So here we have to write these expressions as in exponential form. So they're given to us in log form. So we're given log base 15 of y equals x. And so we're going to write that in exponential form. So here I would pick out the base first. So 15 to the x power, because the log is x. The log is an exponent. So 15 to the x power is equal to y. And then you have it in exponential form. Same thing with number 14. Pick out the base first. The base is 14. The log is 2. So 14 to the second power equals the antilog 196. Okay, the last 6 problems are equations which we have to solve. 3 of those are exponential equations we're going to solve, and then the last 3 are log equations. So number 15 is an exponential equation, and you solve it by taking the log of both sides. That's what we do when you're looking for the exponent with the variables in the exponent and trying to solve for that variable. So we're going to take the log of both sides like you see in the second step there. So log of the left side equals log of the right side. Now we're going to use the property of logs to rewrite the left side. So that's a log of a power. So we're going to take that negative 2n minus 7 and multiply it in parentheses, of course, by log of 16 equals the right side. From here on, it's just algebra. So divide both sides by log of 16 to get that next step. Add 7 to both sides, putting that plus 7 on the end of it away from the fraction. And then finally divide both sides by negative 2. And so you got kind of a complicated looking problem to put in your calculator. So don't try to put that all in at once and you get messed up with parentheses and so on. I would do it in parts. I'd first do log of 3 divided by log of 16 and get that answer. So equals, and then plus 7 equals, and get that next part added in there. And then finally divide by negative 2. So if you kind of break it down into smaller steps, you'll make fewer mistakes. Should get negative 3.6981 then if you did that correctly. So make sure you know how to use your calculator. Okay, next problem is number 16. So again, the variable that we're looking to solve for is up in the exponent. So we're going to have to use logarithms to solve this equation. But first, let's divide both sides by negative 2. That'll give you the second step. Now take the log of both sides in the third step. Apply the log of a power on the left side, so that's going to bring that 7 minus 4b in parentheses down as a multiplier of log of 16 equals the right side. And then algebra takes over, so divide both sides by log of 16. To get the next step, then you're going to subtract 7. Don't rush this. There's too many ways to make a mistake here. So you're going to subtract 7 and put that at the end, and then divide both sides by negative 4. So you got another complicated looking fraction which you can put into your calculator little by little. And if you do that correctly, you'll end up with b equals 1.6049. Okay, I've got one more of those exponential equations in number 17. This time we got 2 things to do before we take the log of both sides, but the first one is to subtract 2 from both sides. Make sure you do this in the correct order, otherwise you will have a mess. So subtract 2 from both sides gives you negative 98 on the right side. Next, divide by negative 7. That's going to give you positive 14 on the right side because that does go into negative 98 evenly. Now at this point, you're going to go ahead and take the log of both sides. So I'm using base 10 there, so log of both sides on the next step. And then, of course, we know the drill by now. You got the log of a power property that you're going to use. So bring down that 2n plus 7 in parentheses and multiply it by log of 5 equals the right side. And then we've done this a couple times already before. Divide both sides of by log of 5. To get the next step, subtract 7 to get the following step. And then go ahead and divide by 2, the entire right side divided by 2. And again, put the numbers in your calculator, piece at a time, not too much. You should get down to n equals negative 2.6801. All right, so that's solving exponential equations. The last three problems then would be to solve log equations. So let's take a look at number 18. Notice on number 18, you got two logs on the left side that are added. So we're going to have to condense those into a single log using our scales that we have. And then we'll go from there. So those logs are added. So we're going to use the log of a product backwards to condense those into a single log. So it's going to be log base 4 of 2 times x equals the right side. All right, we got it condensed into a single log. So now write that equation in exponential form because you want to solve for x. So the base is 4, the base is 4, the log is 4. So 4 to the 4th power equals the antilog 2x. And then just do the math. 4 to the 4th is 256, and then divide by 2. So you should have 128 for your answer for that. And if you check that back up in the problem, we know it's at least in the domain because remember the domain of the log function is positive numbers only, not 0 or negative numbers. So that at least, without checking it all the way, at least it's in the domain, that 128. Okay, 2 more to go, number 19. So this time we've got the difference of logs. Again, we have to condense that into a single log to solve this equation. So the logs are subtracted. We're going to use the log of a quotient property backwards to rewrite or condense that left side into log base 9 of x divided by x minus 5. Okay, so now let's write that in exponential form. So the base is 9, the log is 1, so 9 to the 1st power equals the fraction x over x minus 5. I put the 9 as a fraction on the left side so that you can cross multiply to solve that for x. So one cross product gives us 9 times the quantity x minus 5, and the other cross product gives us just x. Use your algebra skills to distribute the 9. So you got 9x minus 45 equals x. I subtracted x and added 45 both at the same step, and then to get 8x equals 45, and then divide by 8. So you should have x equals 5.625 for that final answer in number 19. Okay, moving right along here. Last but not least is number 20. So again, we have that difference of logs. 2 log terms are subtracted, so we're going to condense them into a single log using the log of a quotient property. And so we're using base 10. Notice that there is no base given, so it's base 10. So we're going to write that as log base 10 of 6 minus 4x over 3 equals 1. We got it condensed into a single log, so now let's change that into exponential form. So 10 to the 1st, again, the 10 comes from the fact that that is the base we're using. So 10 to the 1st power, the log is 1. 10 to the 1st power equals the fraction, 6 minus 4x over 3. And again, I wrote that 10 as a fraction so that you can easily cross multiply. So we have 30 on one cross product equals 6 minus 4x on the other cross product. I added 4x and subtracted 30 from both sides at the same time and divided by 4 to get x equals negative 6. All right, so the best advice I can give you is what I've told you all year long, and that is to just know these 20 problems. You can look at either video a second time. They're both still up if you need to go through and get those explanations again. But know these 20 problems, and you know that your unit test is going to be very, very similar with a few numbers changed. Otherwise, if you know these, you should be in pretty good shape. All right, there you go, and good luck.